Recording. Okay, so quick reminders that now by the end of this lecture, you'll have all of the info that you need to complete homework C6. And so today is the day that the homework C6 is formally assigned, and I think it's due, I don't know, it's about 2 weeks from now. The due date is on Canvas in particular. So half of C6 is kind of about cardinal social welfare, so some of the previous stuff from the beginning of this unit, and then the other half is doing kind of a market failure example, a kind of a more mathematical market failure example where you actually have to draw out some things and calculate deadweight loss and things like that. And so we will get into that today so that you'll have sort of all the tools you need for that. And then we'll continue to talk about that on Thursday. So we'll have more of that. Then Tuesday is, so I guess I could make kind of some notes about this. So I'll just write, homework C6 is available, and you should be ready for it by today. And then Thursday we'll again do more of the stuff, and then Tuesday is normally the day that we would have like a fall break. And so normally that would be a day that would be canceled. Now I can move classes forward and change kind of the original schedule. I kind of like to avoid doing that because I have to go through and manually edit a bunch of due dates in Canvas just to manually revert them the next time I teach this course. And so what I was thinking of is on Tuesday to make an optional lecture where we can continue to work some of these market examples, these kind of more numerical ones, and so that we have some more practice at doing things like calculating things like producer surplus, consumer surplus, deadweight loss, things like that under different market failure conditions. And so that'll be something where I could show up on Tuesday, and I'll send in a Canvas announcement about this. Well, if nobody shows up, then that's fine. I'll just end early. If people do show up and want to work some examples, we can do that, and the session will be recorded for anybody who doesn't show up. And so that's kind of what I'm thinking of doing for what would normally be fall break, but we don't have fall break. And so rather than trying to move forward all of the other lectures, just kind of make use of it to provide us a little extra breathing room and practice for this type of stuff. So that's kind of my plan moving forward. So I'll write that down here. So Tuesday plan is optional lecture for, we'll say, problem practice. And that's supposed to be practice. And that's particularly like market failure problems. And then if no one shows up, just ends early. Otherwise, recorded. All right, so that's the plan there. All that's been recorded there. So are there any questions about any of the stuff moving forward, the schedule, etc.? If not, then we can keep rolling here. So last time, maybe I'll just start on a fresh page here so that it's, I don't know, I guess we can do it here. So last time, we had just finished talking about how we were moving from cardinal social welfare to these kind of Pareto-like frameworks, specifically Kaldor Hicks, and that allows us to have some ways to think about markets. And so we talked about that markets, the key features of markets is that they are decentralized. And so by decentralized, I mean that there's not an auctioneer where everyone goes to in order to exchange. A market can happen anywhere. So, you can buy a good wherever you bump into somebody who sells that good. It doesn't have to be all in one place, and you can agree on a price, and you can and then you can exchange, money or one good for another good. So its markets are decentralized collections of buyers and sellers, and those buyers we are often referring to as consumers, and sellers, who we often refer to as producers, whose interactions determine the allocation of goods, and I guess I should maybe also say, and services and monetary benefits through exchange. And so there's a lot here that we can unpack. And so the idea here is that if you had a bunch of bread, for example, you could just say that everyone gets a certain amount of bread, and you just give that amount of bread to every person. That is one way to allocate bread. Another way to allocate bread is to allow people to trade bread. And so some people have gone through the process of making the bread, and some people have decided that they don't want to make the bread, but they've done other things that can allow them to trade the bread with those people. So ultimately, this decentralized exchange is one way that you can make sure that bread gets to people, and gets to people in a way where the allocation kind of self-organizes through the market. And so when we think about markets, we think, as economists, we think about markets more broadly as one way you can allocate things. It's not just about like, how do we get people to buy and sell stuff? Like, the bigger picture is like, there's a bunch of different ways you can allocate stuff throughout a society, and markets are one of those. And as sustainability economists, then what we need to think about is there are certain aspects of human life that maybe are not captured by markets naturally. And so are there ways in which we can think about market-based interventions that can also allocate those things in these ways? And that's kind of what we're going to be talking about here, is that a lot of times when people talk about market-based solutions to sustainability problems, it starts sounding like I think a lot of people wouldn't necessarily expect that. They think that, like, well, maybe economics should be like counter to environment or counter to conservation. But in reality, if you can look at conservation, you can look at sustainability, all these environmental problems through the lens of economics. And what you find out is actually a lot of these problems are not caused by markets. They're actually caused by there not being enough markets. So it's not that the markets are currently there are causing overconsumption. It's that overconsumption is happening because we've got environmental goods that are being allocated in a non-market-based way. And if those environmental goods were allocated in a market-based way, then we might actually have a better chance of conserving them. And so that's kind of what we're getting into today. All right, so those are markets. And the key aspect to markets we talked about is supply and demand. And so we were saying that the actions of buyers and sellers reach some, and we'll use the term equilibrium. And this equilibrium is a kind, we might also call it a steady state. And by steady state, what I mean is, initially, when you just throw all of the goods out there and allow people to start exchanging, there's a lot of exchange and prices are changing and all sorts of things. But eventually, the price of the goods settles down. And you end up getting kind of a steady state exchange where you kind of know exactly, it's not like initially where like there's a bunch of goods were exchanged and then suddenly there were very few goods exchanged. You end up kind of reaching some steady state, some background level of exchange that happens at some sort of stable price. And so we often use this term stable is a term we use that describes an equilibrium that automatically is restored when, or I could say after, a temporary disturbance.
Professor, I got a quick question.
Absolutely, go ahead.
No, is this stuff right here, right now, this is what we learned last time, or like are we doing like a recap, or is this currently new at the moment?
Well, it's a recap.
Okay, just
And so I'm
making
done.
sure.
Yeah. So yeah, we'll get to new stuff in here just in a second. I just want to make sure we're all on the same page.
Yeah, I got it.
So this word stable, so it has a very precise mathematical definition. I'm not going to go quite into that, but this is sort of a summary of stable. And so this is the term I'm looking for, that like we generally view markets as reaching these stable equilibria, and they particularly do that when our supply and demand curves, which I'll remind us of again, have this nice X shape, where supply is going down where supply is going up and demand is coming down, and where they interact or intersect is one of these stable equilibria, which, and by that I mean that if you were to somehow rock the market by injecting a bunch more goods or something like that, the market would maybe temporarily, the price would shift up or shift down, but then it would eventually settle back down at that stable equilibrium where supply meets demand. So the mathematical picture of this that we're going to now start using over and over again is this axis, these axes where we've got the quantity of a good. So I'll say quantity of a good. And this quantity, this could be bread, but this also could be pollution abatement. So, it's any, good that you can think of here. And then we have the dollars per quantity. So that's the unit over here. And so we'll then have our demand curve. So I'll just write demand down here. I'll try to write demand down here. And we then have the supply curve. And if we remember, the supply curve represents what producers are willing to accept for the next unit of the good. And the demand curve is what consumers are willing to pay for the next unit of the good. And these two things come into equilibrium right here, where demand equals supply. And that happens right where they cross. So if I gave you a function that represented the supply and the demand, if you set them equal to each other and you solved, then you would end up finding that there would be some level, we'll call it Q sub n, of quantity that brings those equal to each other. And then if you plugged that quantity into the demand curve or the supply curve, both of them would agree on the market price over here. And so we have this allocation. This market equilibrium is a combination. I'll say QM comma PM. That is an equilibrium allocation of goods. It's an equilibrium price and quantity. And so this is just a natural place that when you throw things together into this market, then things kind of settle there. And so that's what we mean by the equilibrium level, or the market. If I just say what is the market price or the market equilibrium price or the equilibrium price, just those, I'm referring to this PM and QM. It's where supply meets demand. And so this is an allocation of goods and monetary benefits to society. And so this is for, I mean, if we talk about, we know that there's a, if we just remind ourselves that there's this, this choke price that's up here, and this is the market choke price or the total choke price, which means that there is some sucker in the market who's willing to pay that much for this good. That's a lot of money and they're willing to pay it. But once the price goes over that nobody is willing to pay that much for the good. But down here at this lower price here, then there are some people that are willing to pay for this good, but there are others that aren't. And so by setting a price, then and then getting a quantity out, we have made decisions implicitly that we are going to put this much quantity of the good available in the marketplace, available to society, and we are going to distribute it among society to those who are willing to pay this amount over here. So, just saying that there's a market is saying something so much stronger. You're saying that you have allowed a self-organized, decentralized process to decide how much of a particular good is to be produced and who gets it. You are not at a central government level deciding who's doing that. You're letting the market do it. So that's what we mean by it. It's a way to allocate goods. But, so then that brings up, that suggests the question, is this a good allocation? I guess I should put good of goods. There are a bunch of different ways we could choose to allocate this quantity of goods. Is this the best way to do it? Does this meet our societal goals? And so how do we determine that? If you think about, if you took history or a microeconomics course, I'm sure you've heard of Adam Smith and the so-called invisible hand, which is this basic idea that people driven by their own self-interest, just trading things together, should, in the Adam Smith theory, naturally come to an efficient, or I don't want to use the word efficient just yet, but naturally will come to an allocation that is favorable to society. That's what Adam Smith was sort of saying, that there was some invisible hand, not a central government, that was naturally, and we should just trust the invisible hand, that it's always going to work. But, since then, what we found is that there need to be certain conditions in place that ensure that this is a fair or the correct, allocation of goods to society. And in order for us to get there, the first thing we need to sort of say is, well, like what, how do we measure the benefits to society here? And if we just, on this graph here, if I were to just draw a line across at price, then this price represents the benefit that producers are getting for selling their good, and it also represents the cost the consumers are paying for buying that good. So we know that if we can call the top line benefits, so let's say that for now I'll just put, is this really the marginal benefit curve? Let's just assume for now it is. And is this down here really the marginal cost curve? And let's assume now that it is. If it is, then everything in between the marginal benefit and the marginal cost in this space that I'll sort of highlight here, this represents the net benefit to society. And that net benefit to society is going to be split up between two triangles. This is the consumer surplus up here and the producer surplus down here. And so we can write that in, the producer surplus or the consumer surplus, and then down here, the producer surplus. And you can think of these, we'll use that. So the consumer surplus is the share of the benefit to the society that's allocated to consumers. And the producer surplus is the share of the benefit to society that is allocated to producers. And so you can view these as two utility functions, where this is kind of like the utility function for consumers. And then down here, this is like the utility function for producers. So this whole triangle here and this whole triangle here. And so now we've got two utility functions or two classes of people, and we want to ask, is this Kaldor-Hicks efficient with respect to these two utility functions? Is this allocation over here Kaldor-Hicks efficient? That's kind of the big question. Adam Smith would say, sure, it is. But we want to sort of better understand the conditions that make that happen. So that's kind of what we're talking about today. So ideally, so what do we need? So I mean, the shorthand here is for markets to be efficient. And I'm going to put Kaldor-Hicks here, efficient. The big things that we need is that supply needs to be equivalent to the societal, so I'm going to put S in C, where this is societal market cost or marginal cost, and demand needs to be equal to the, and I'm going to put a societal marginal benefit. And we'll see what I mean by that as we go through these specific conditions. And so the question is, what do we need to ensure that happens? So how to make sure that this is the case. And so the conditions that we need is, the first one we need here is that we need to be sure that markets are, and we're going to use this term, competitive. And so the formal way that we say this is that market participants must take prices as a given. And I'll unpack that statement in just a second. But that's kind of the common way you say this, is that market participants must take prices as given. And what I mean by that is that, and this goes along with being competitive, if somebody says, I will sell you this green ball for a particular price, and you don't like that price, you should be free to go to someone else who is willing to offer a lower price. And that should make someone else willing to offer you a lower price. And so there's no price fixing. So this basically says is you cannot arbitrarily fix a price. And so this usually happens on the side of producers. And so if you happen to be the only one producing a good for which there is a significant demand, then you may have the ability to price fix. even though your cost curve looks like a particular shape, you can ignore your cost curve, and you can just arbitrarily say that I am going to charge, you know, $20 per green ball, regardless of even, you know, how much it costs me to buy this green ball. And so I can just arbitrarily say that the first green ball, even though if a lot of people were selling these green balls, the first green ball I might have to sell for pennies, because there would be a lot of other places out there you could buy the green ball. If I'm the only one that sells these green balls, then the first green ball I can sell for whatever I want to sell it for. And so it's not competitive if I own all of the production. And so that's what a market being competitive means, that no one has a disproportionate role over fixing prices. And so I can say that no one has a disproportionate role or disproportionate influence on prices. And, you know, firms, you know, another way to say that is firms and consumers are unable to manipulate prices. All right, so why is that important, and how do we see that in this sort of diagram here? Well, if I were to then go back and, you know, draw a simple one of these market diagrams, I'm going to draw two just to make sure I leave myself some space. So this over here is going to be on the right hand side is going to be the competitive. And over here, this is going to be the non-competitive. And so in both of these, I'm going to draw the same supply and demand curves. So if I was smart, I would have drawn the left one and then copied and pasted it. But I know that, you know, you guys aren't necessarily copying pasting, so I'll go through the drawing with you. So so I can draw my curves here. And so this is my supply curve, and this is my demand curve. Actually, I'm not going to label them as supply and demand. I'm going to say that I'm going to call this one here that's my demand curve, I am going to call it the marginal benefit curve. And this one that's going up here, I am going to call it the marginal cost curve. Now, well, we'll see, you know, what happens here in a second, but we know that we want marginal cost to equal marginal benefits. That's where society receives the most benefit. But whereas I'm saying in the non-competitive side, I'm going to assert that, okay, that my demand is equal to the marginal benefit. Let's just say we don't have to worry about demand. But I'm going to say that in the non-competitive side, then the producer just has decided to set a price, and that they're just free to set a price. So even though the producer's cost is going to be determined by this marginal cost curve, they're just going to arbitrarily set a price. And so let's say that they decide to set their supply curve to be this price. So I could just draw a little dotted line over here maybe, and I'll call this the supply. And I'll say it's not equal to the marginal cost. So I'm just saying that the supply curve is flat. They are only selling it for this much. Well, what happens if they only sell it for this much? Then this here is how much the consumers are going to be willing to buy. So down here, this will be our market equilibrium and our market price. And that's going to mean, maybe I'll flip to a different color, go back to the blue. And that's going to mean that the consumer surplus up here is going to be pretty tiny, and the producer surplus down here is going to be relatively large. And so if I were to highlight that, this is my consumer surplus, pretty tiny. This is my producer surplus, pretty large down here. And I think in the notes that I posted online, I actually gave, you know, numbers here. And so So I gave an example where the, let's see, if I wrote down a line here, yeah, it looks like, all right, so let's say for example, if my demand curve was be equal to, we'll call this 4 minus Q. So this starts up here at 4, and then it also ends down here at 4. And let's say that my supply curve or my marginal cost curve is, I think I just made it equal to Q. So this marginal cost curve here starts down here at 0, and then it's up here at 4. So these are supposed to match. So it's kind of, if I would have drawn this, if I would have been more careful, then this would have pierced to this point up here. So the idea here is that this is supposed to have a slope of 1, and this is how you're also supposed to have a slope of 1, so that where they intersect here is supposed to be at 2, 2. So they're supposed to intersect at a price of 2 and a quantity of 2. But if I force my price to be, let's say, 3, then instead they're going to intersect at this point here, which is going to be at a quantity of 1 and a price of 3. That's where they actually reach the market equilibrium. And so we can then calculate the consumer surplus and the producer surplus for this particular case. And what you'd find is for this top one, because this triangle has got a height of 1 and a width of 1, the consumer surplus for this case over here is going to be 1/2 times 1 times 1, which is just equal to 1/2. But the producer surplus is this funny looking trapezoid shape down here, which if you'd like, you can split into a rectangle and a triangle. So this rectangle portion that I can put this kind of laser here has got a width of 1 and a height of 2. So this portion of the rectangle is going to be equal to 2. And then this little triangle down here is equal to this triangle up here. And so the producer surplus, if I add both of those things together, gives me a 2.5. So producers are doing way better than consumers. But that's okay. That's not necessarily a bad thing. The producers are doing better than consumers. What the question is this a Kaldor-Hicks equilibrium? And what it turns out is that if instead producers were in a competitive market where they couldn't just set a price, then we would be more like what's happening on the right-hand side, where instead the equilibrium would actually, if the supply curve equaled the marginal cost curve down here, then they would come into balance right here at the 2, 2 point that was mentioned over there. And at that point, the producer surplus and consumer surplus are both equal to CS is equal to PS is equal to 1/2 times a height of the triangle of 2, a width of the triangle of 2, which in this case is just going to be equal to 2. So what we've done is we've gone down in producer utility, but we've gone up in consumer utility more than we went down in producer utility. So the point here is that from the non-competitive to competitive, we see that we've gone from the utility to the consumer has gone from 0.5 to 2, which is a 1.5 difference. And the utility to the producer has gone from 2.5 to 2, which is a negative 0.5 difference. And so, and I guess I can re-highlight these. So it turns out that the non-competitive equilibrium was not Kaldor-Hicks efficient. because there was a way for us to adjust the price to bring more utility to the consumers, so much so that the utility lost to the producers was dwarfed by it. So this over here indicates that this change was a Kaldor-Hicks improvement. So I guess I could draw this. All right, so it's not a Pareto improvement. These are actually both Pareto efficient in the strict sense of Pareto, but it is a Kaldor-Hicks improvement because we were able to overall improve things kind of for the society taken as a whole. Because even though we decreased a little bit of the benefit that was going to the producers, we more increased the benefit going to the consumers, to the point where consumers could, in principle, if they wanted to, compensate the producers for their losses and still end up better off than they were before. And that's what is kind of being shown over here. So that's, step one, markets have to be competitive. And if you go from non-competitive to competitive, you can get a Kaldor-Hicks improvement. Right, so that was a lot. Is there questions about that? Do you see how competitive markets lead to Kaldor-Hicks improvements? They bring us closer to efficient markets, where efficient markets are markets where there is no Kaldor-Hicks improvement.
Got a question about measuring both of them. Ava asked this in the chat.
Oh, I'm sorry. Go ahead.
She asked that, like, and also same question here, is it measured in like dollars or a different type of measurement, like when you measure these?
Again, I apologize for not seeing the chat. I'm moving the chat higher on my screen. So that's an excellent question. So this is because these areas are measured in dollars, and I guess I could have put, again, my units here, is that the demand and supply curves are measured in dollars per unit quantity. And so the area underneath them is going to be the units on the y-axis times the units on the x-axis, which gets rid of the quantity. So these are measured in dollars. And you say, well, what do you mean measured in dollars? Well, the idea would be that that it goes back to kind of what we did in some of the earlier chapters, where I can ask you, how much is this good worth to you? And we can sort of accumulate, okay, if every unit of the good is worth this much and you have this many units, then I can then accumulate that if I have 50 green balls, I can actually calculate how many dollars worth those 50 green balls are to you. And that's kind of what this consumer surplus is the accumulated benefit across all of the consumers in the market for having access to these goods. I don't have the money available, but I have the bread. So the bread is worth the money that I lost to get the bread.
Okay, so what our main goal for Kaldor-Hicks is to make sure that marginal cost equals marginal benefit in Kaldor-Hicks?
Well, it just so happens that that when your marginal benefit equals your marginal cost, there will not be any Kaldor-Hicks improvements you can make in a market system. And so I could have also reformulated this problem in terms of strict utilitarianism. Like I could have said that we have a cardinal welfare function, which is UP plus UC so I meant to say cardinal social welfare function. That would be an alternative way to come to the same result. So the cardinal social welfare function could have been this thing here, which is just total utility. And then that's another way of saying that, like, well, the total utility here is only 3, and the total utility here is 4. And so if we care about total utility, then this also was a good way to do it. But we prefer using the Kaldor-Hicks framework because it's kind of a more objective way to get to the same thing. And most of the time they're going to agree at equilibrium, but kind of how you get there is going to be a little bit different, if that makes sense.
Yeah, I think so. All right, thank you.
Okay. Let me make sure there are other questions. Oh, so there's a question, do we want we actually, we like both consumer and producer surplus. Society is made of both consumers and producers. And so it's not that we want to reduce the producer surplus. Wasn't the lesson that I was trying to impart here. The lesson here was that with a little bit of a reduction in how good the producers are doing, we can greatly increase how well the consumers are doing. And so they're still at the efficient equilibrium. Producers are still doing quite well. They're just not doing quite as well as they were at the non-competitive equilibrium. So at the competitive equilibrium, both consumers and producers are getting a lot of benefit. It just so happens in this particular problem, they're both getting an equal amount of benefit. That won't necessarily happen all the time, depending on the shapes of all these curves and so on. But when we have these linear curves, that happens to be that you end up kind of sharing this equally. But you can imagine that if your actual marginal cost curve was kind of curvy shaped and your marginal benefits curve was another type of curvy shape, you could imagine equilibria where even though it was where the marginal cost equals the marginal benefit, the producer surplus would not be equal to the consumer surplus. So if I were to draw that with a laser pointer, if this was kind of curved up and if this was kind of curved down, they might intersect somewhere here, and the areas, the producer surplus and the consumer surplus would be a different shape, and they'd have different amounts. So that makes sense. We're trying to balance our societal benefits between our consumers and producers. That's a kind of Kaldor-Hicks idea. All right, so that right there is what you normally would talk about in a microeconomics course. You'd focus on this competitive aspect of markets. And it turns out, this is important. Oh, and I guess I should mention one more thing that I almost forgot. Notice there's this region of the triangle, which is lost social welfare. That lost social welfare is what we refer to as deadweight loss. Or DWL, and that is just lost social welfare. And so in each one of these examples where it is convenient to draw these market diagrams, when we go from the non-competitive side to the competitive side, we should be able to calculate the deadweight loss to society. And the deadweight loss to society here, well, I already sort of calculated that the total benefit to society in the competitive case is 4. I guess I could write that's the total benefit. And the total benefit to society here is 3. And if you thought about this, the area of this yellow triangle inside here, then the area of that yellow triangle is going to be the difference between those two, which in this case is going to be that 1. And so it's kind of like the vertical leg of that triangle is going to be of height 2, and the width of that triangle will be height 1. So we do 1/2 height times width, you end up getting 1 out of that. So deadweight loss is the term, DWL is the term that we're going to use over and over again for the amount lost just to bad configurations of allocations of good. So it's this like weird kind of fuzzy thing where it's like if we lived in a world where we were at a competitive equilibrium, the society would be doing better by this amount of loss. So that's what we mean by deadweight loss. Any questions about that? Deadweight loss and how it's the portion of the triangle that's not filled out, the inefficient equilibrium. Or it's the amount of gains we would get if we were to move to the efficient equilibrium. Okay, so that's the first thing we need. We need 3 things total. The second thing that we need is we need that information symmetry. And what I mean by information symmetry is that we need info about goods to be understood equally by buyers and sellers. And this helps to ensure that, for example, the perceived marginal benefit is equal to the actual marginal benefit. So you can think the perceived marginal benefit might actually refer to, the demand for the good. But if you perceive that it's going to benefit you this much, but then you buy it and it actually benefits you a whole lot less, and you realize that the reason that, and you realize that the seller actually, like you might have, the seller might actually know this, and because they know that your perceived benefit is different than your actual benefit, then they can perhaps get you to pay a price that is higher than the price you actually should pay. And so this is another way that demand can end up not equaling marginal benefits. And you can probably cook up examples where costs, where supply is not necessarily equal to the actual marginal cost, but that's more the kind of third case. So this is primarily focused in these demand type examples. So can anybody think of examples of this where the buyer and seller have a different relationship to information about the goods? Anybody? There are some classic examples I think that were mentioned in the textbook. And then maybe you've got some examples from your own life where after you bought something, you had a little buyer's remorse when you actually started using it. No one? Really?
An example could be like a car, like a used car, right? Is that something like?
That is the classic example.
Yeah, I remember that from the reading, which honestly they've been really helpful.
Good, good. So yeah, used car sales is a great example of this. And maybe this is a stereotype, and I apologize if any of you are used car salesmen or saleswomen or have some in your family. But this is kind of the classic example where a car looks, so this case, the car looks, maybe even like new, but the salesperson, so the producer, knows its flaws and maybe its history, and you take it but the seller has no access to that. You might take it for a test drive, but a test drive doesn't tell you that in a week or two that the transmission is going to fall out of the bottom of the vehicle or something like that. And so you try to have an expert look at it to gain information, but ultimately the salesperson has had more access to that than you. And so you end up buying it thinking that it is one thing, but then after you buy it, you find out that it is something else. And so this also happens in homes. So the first time you buy a home, you're not actually allowed usually to talk to the person selling the home. Your realtors interact with each other. You might meet with the other realtor, but you're probably not going to meet with the person selling the home. And part of the reason they do that is to prevent you from the sellers letting something slip or the producers getting more information out of it. So the real estate market is kind of built on information asymmetry. And then you get in your home and you find out that, oh, wow, it looks like the disposal's been leaking. Well, I didn't realize that in our home inspection because they had cleaned out the evidence of the leaks, or I didn't realize that there was this damage that was behind the walls because it's been hidden behind the walls. So these are examples where information asymmetry makes you perceive a benefit that's higher than the actual benefit, or perceive that costs are lower than the actual costs. And so that's another problem. This is not usually a problem we worry about in sustainability as much, but it still can be important to keep in mind because we're talking about aligning agendas and marketing ideas to people. And people, for example, you might market plastic as being a really efficient product, But really what you're holding back is that you know as a plastic manufacturer that there's almost no way to recycle plastic. And so holding that information back from someone can lead to sustainability problems, because all of the people buying the plastic will end up thinking that the plastic maybe is more recyclable than it actually is. So that is kind of an example of information asymmetry. Is there a question? Sorry, I saw a microphone go off. No, okay, good, all right. All right, so let's then focus in, so that was great. So then, but the third one that's really important for sustainability problems is completeness. So markets must be complete. And what we mean by that is that buyers and sellers must pay all production costs and enjoy all benefits and so what we mean by that is that if you're producing a good and someone else pays a cost, every time you choose to produce that good, the cost that someone else is paying is not going to go into your decision making. And so that is an incomplete market. Likewise, if you receive benefits for a good that that you're not paying for, you just get them for free, then that is also going to be an incomplete market. And so I can actually demonstrate both of those things with pollution. So you can imagine that carbon dioxide, is let's think about CO2. It happens for both sides of this. So on the emission side of things, you can have that on production, you have CO2 emissions are globally costly, but only a small fraction of that cost is felt by CO2 producers. And so this is an example where the private marginal cost is not equal to the societal marginal cost. So those making decisions about emitting CO2 are not actually feeling the costs that they're putting there. The costs might not even be, like, the costs might be paid by someone miles away, or miles and hours, or days, or months away. And so we're not just talking about costs paid by people, other people in the current time at a different space, but even other people in other times. If they're paying the costs for your consumption now, then it is not a complete market. This also goes on the side of goods. So this is, that was the cost example. But if we think in terms of abatement, then we can talk about, emissions, or I'll say pollution abatement, for example. Remember, pollution abatement is a good that is felt by all, even those who do not contribute to securing it. And so you got 5 factories all down a line. 4 of them decide to install scrubbers, so they have purchased abatement. The 5th one doesn't. The 5th one continues to emit, just like the other 4 factories do. The 5th one enjoys all the benefits of that abatement. And the benefits could be, benefits to the local air quality. They could also be that because the local air quality has gotten better, that maybe there are maybe there are local regulations that now the fifth one doesn't have to worry about because the global air quality has gotten better. And so in that case, you get this kind of free rider problem where the fifth one has no incentive to actually spend more on the abatement because it is enjoying all the benefits of the other ones who've done that abatement. So that's just the kind of CO2 example, but I think you can think of lots of other examples that are even outside of the environmental realm. Your neighbor installs a really nice front yard landscaping that actually makes the rest of your cul-de-sac look better. And so you end up, the value of your house goes up because your neighbor has invested in making your cul-de-sac look better. Well, that is a positive benefit that you didn't pay for that you're getting from all of your neighbor's investment. So, there's lots of cases of positive externalities and negative externalities. And so this here is an example of a negative externality. And this down here is the example of a positive externality. And so this term externality is just a cost or benefit that is external to the decision-making of the participants, regardless of the buyers or sellers. So I guess I should write that on a separate page here. Externality is a term you should become very familiar with. And we can say this is a cost or benefit that is external to the decision making or to the decision maker. And so whenever you have actions of one individual or firm that are that have a direct, unintentional, and uncompensated effect on the well-being of other individuals or the profits of other firms, you have an externality. So, if you want some other examples, then I can say like, there's a cost felt by those around a smoker in a public space because the smoker can smoke and is imparting a cost to others. So the others were not involved in that decision. And or if you like something a little larger scale, you can say hydroelectric dam. So a hydroelectric dam puts a cost on salmon fisheries. So the hydroelectric people, they're not in the salmon business. They don't need to think about the salmon business, right? So the hydroelectric dam, they put up their dam and they start generating electricity. That sounds like a good thing. But downstream, it is going to affect the livelihood of salmon fisheries. And so, so that's an example where because they weren't thinking about the salmon fisheries, but there was this environmental impact, then that's why we have things like environmental impact statements. Is that it hopes to make these externalities more focal. Is there a question?
Remember with our groups on our amino acids, we have like acidic amino acids, basic amino acids, polar and non-polar, all that stuff, right? So those enzymes, they might be in the environment for these bonds to break.
No sex for a week.
So that's why this.
All right, I think for a week. I think we had an unmuted mic. All right, so everything's muted then again. So, so are there any questions about this idea of externalities? Is it clear what an externality is? Can it be positive, a benefit, or negative, a cost? But it is just caused by someone who has made a decision and either either you haven't made a decision and you're paying the cost or benefits from someone else's decision, or you've made a decision and some of the benefits or costs of your decision are going to be felt by someone else not involved in the decision making. Is that clear? All right. So so then how do externalities lead to deadweight loss? And so this is a graph that you should become pretty familiar with, and I think you'll have some practice with on your homework. And so if we go back to thinking about this curve, or these market curves, we've got a quantity here that is being produced. So you can think about this as like the quantity of a good that's being produced. So quantity of good being produced. And this is a good. So we are, and so there is some benefit to having that good. And so I'm just going to draw a benefit line here, and all right, I'm not going to draw any. I could give you a formula for this line, but I'm just going to draw this in the abstract here. And so we are going to assume that the demand is equal to the societal marginal benefit. So that's good. But there are two cost curves we have to worry about. There is we'll say here, we have this is the private marginal cost, which is equal to the supply. So this is how much it actually costs the supplier just locally, how much the supplier notes on their books, how much it costs to supply this good. And so it increases over time, as we've discussed in the past, and we reach some market equilibrium that is right here. So that right there is going to be the equilibrium quantity, and this will be the equilibrium price. That is actually what's going to happen. But the problem here is that there is an additional cost paid to society, or paid by society, that we're going to put down here, that I'm going to call the marginal damage. Or MD. And I could give you a formula for marginal damage. So I could give you a formula for private marginal cost. So this is, sometimes I'll just write this as PMC. I could give you a formula for marginal damage. I could give you a formula for marginal benefit or demand. And you could find where all these things intersect, okay? So the real cost to society is going to be the cost the supplier pays, the private marginal cost, plus the marginal damage. And so there is a real cost to society, which I can draw up here, which is the SMC, or the societal marginal cost. And here the SMC is just equal to the PMC then plus the marginal damage. So I could give you an expression for marginal damage. I could give you an expression for private marginal cost, and you could add all those things together, and you would get an expression for societal marginal cost. And then that would give you this third line. That line is what the marginal cost, that is what the supply curve should be. That, in a perfect world, is what the supply curve would be if the supplier would actually, if the producer would internalize all the costs that they're putting on the environment. So you can think of the marginal damage curve over here as being, so example, the marginal damage might be pollution emitted into air. If the supplier actually felt all of the damages that are just being released into the air, then their marginal cost curve would shift up to the purple curve, to the societal marginal cost, but they don't. And because they don't, and that's lost, then they only see on their books the red curve. Now, if it was that perfect world where they felt it all, then this point over here, that would be the Q star, and this here would be the P star. And so this Q star, P star is the socially efficient equilibrium. Whereas the other one is just the market equilibrium. So I can say this QM, PM is the market equilibrium.
I got another quick question about the this graph
Sure.
of externalities. So so with the marginal damage, is this insinuating that this is a negative externality?
That's right. This is a negative externality because it is a cost paid by someone else.
Yeah, so but if it were to be a positive externality, would that mean that SMC would be lower?
I'll show you a positive externality on Thursday, which would be kind of like a public goods example.
Okay, got it.
All right, so for this negative externality, then what we can do is we can look at this and we can say, all right, so the producer surplus, so remember they're actually producing way more than they should, and they're at a price way less than they should. So if it was socially efficient, it would be this, how to sort of say this? Well, okay, maybe I'll just draw the lines here. So so this, I guess I'll just write here that this is the price is too low and the quantity is too much. All right, and so now if I highlight all of these things here, then what I can do is I can say, well, all right, so that the market equilibrium, I'm trying to decide which way I want to draw this, and that's why I'm hesitating here. So if we were to imagine things were at the market equilibrium, so at the socially efficient equilibrium. So if things were at the socially efficient equilibrium, then this area that I'm highlighting here, that there is the producer surplus. Oh, shoot. That area right there is the producer surplus at the socially efficient equilibrium. And the area above it here, this here is the consumer surplus at the efficient equilibrium as well. Is that area there. And so if we were to ask producers to pay, to charge a higher price, then the producers would say, why would we charge that higher price? Because they're tempted, because they could say we can end up increasing our producer surplus and we can actually provide more goods to the consumer. We can actually increase the consumer surplus if we just lower the price from the socially efficient one. So if I was trying to get them to set their prices at P star, then they're going to resist me and say, no, we want to set our prices at PM. And so this orange area, I guess I'll make it orange area underneath here, this area here this represents that temptation. So you can view this as the lost CS and PS at the efficient equilibrium. So this is the stuff that on the books, on the accounting books, this actually looks like what they're losing by not charging a lower price, if you were to manage to force them to charge a higher price. And you might say, well, it looks, like, so why don't you just let them charge the lower price and produce more? Well, the triangle above that, so if I were to maybe highlight that in, maybe I'll do gray. The triangle above this here, this is the deadweight loss to society. At the market equilibrium. So the idea here is that if I allowed them to charge this price here and produce this quantity here, then although they would pick up, or society would pick up this little triangle down here, what it also would pick up is this bigger triangle up here of deadweight loss, which represents the additional accumulated cost due to the marginal damages. So this smaller triangle that you appear to be picking up is offset more than by these damages here. And so that's the reason why this is actually the efficient equilibrium, is that even though it appears like you're losing out, you're actually gaining because you are also getting rid of this additional damage that you're done that was not accounted for because it was an externality. So when we have these negative externalities, we're typically going to we're going to model the externality as a marginal damage curve. You're going to add it to the private supply curve, and that's going to give you a societal marginal cost curve, which will allow you to calculate where things should be if all those damages were included into the system. And you can compare that to where things are when those damages aren't included in the system. And then that will allow you to calculate the deadweight loss up here, as well as all of these other factors like the consumer surplus and producer surplus at the efficient equilibrium, or I guess you could also calculate it at the market if you would like, and then compare how things end up working out. But when you do calculate it here, you have to also include that deadweight loss. So at the market equilibrium, you've got this giant triangle of benefits to society minus this little gray triangle of costs. And that's the thing that, if not advertised, it appears like the bigger triangle is better, when in reality, this trapezoid brings you higher societal benefits. All right. So the rest is we'll start talking about then on Thursday. I want to stop here, but I want to make sure that there's a minute or two left. And so, are there questions about this graph, about this new marginal damage curve that we've added, which forced us to also add this societal marginal cost curve and makes this a little more complicated?
Just making sure, you said that the deadweight loss that we had right now is actually beneficial.
Well, the getting rid of it. So if we're at this amount of production, so Q star, then we manage to stave off the deadweight loss.
Okay.
And so that's what I'm sort of saying, is that if you didn't think about this, you might say, let's produce more. Let's just go to here. But when you go to here, you're not only picking up this lower triangle, you're also picking up this upper triangle, which is a negative, or it's a cost to society.
Okay, got it. Thank you.
Yeah, remember, whenever the marginal benefit and marginal cost curves cross, the areas on the right-hand side of the cross are negative. So on the left-hand side are positive, on the right-hand side are negative. And that's why if this is actually the marginal benefit, marginal cost cross, then this gray area is taking away, not adding. Any other questions? All right. So, sorry, then let's then end with an attendance question. And so I'll put the link in the chat as well. And so I guess the question I'm going to say is, what does MD stand for when we model externalities in this market framework? So what was that line that I drew that extra line and I labeled it MD? So what does that stand for? And otherwise, that's all I've got for you today. So if you'd like, you can leave. If you've got any other questions, I'm happy to stick around for a few minutes.
Thank you.
Thank you, Professor.
Yep. Have a good day.
Thanks so much.
All right. Well, if there's no other questions, then I'll go ahead and end the meeting.